Quantum entanglement is the worst explained idea in physics, and the explanation almost everyone reaches for is not just simplified. It is the exact thing that was proven wrong. Here is that explanation. A pair of gloves, one left, one right, seal them in two identical boxes without looking. You keep one, the other gets shipped to the far side of the planet. You open yours, left, and in that instant you know with total certainty what is in the other box. Nothing traveled, nothing was sent, because the answer was fixed the moment the boxes were packed. The only thing that changed when you looked was your own ignorance. Entanglement is not that. And the reason it is not that is the most underrated result of 20th century physics, so let us build it properly. Start with how you make a pair. One event. An atom decays or a crystal splits a photon, and two particles come out. Because they came from one event, a conservation law ties them together. Whatever the total was going in has to be the total coming out. Say the total spin has to be 0. So if one is spin up, the other has to be spin down. Their sum is locked. That part is just bookkeeping. Here is the part that is not bookkeeping. Neither particle has a spin yet, not a spin you happen not to know, not a value written somewhere you cannot see. There is no answer there yet. The pair has a definite relationship. The halves have no definite state. That one sentence is the entire subject. Now measure. A spin has no label you can just read off. You have to pick a direction first and ask whether the spin is up or down along that axis. And you always get one of exactly two answers, whichever direction you pick. Point both detectors the same way, you get up. Your partner, however far away, gets down. Run it 1,000 times. Your row on its own is a coin flip. 50-50, no pattern, nothing you could have predicted. Line the two rows up and they are perfect mirror images, every single pair. And here is where almost everyone says the obvious thing, including some very good physicists for about 30 years. Fine, they agreed in advance. The particles left the source carrying instructions. If anyone asks, say up. Then the other one says down, gloves with extra steps. That idea has a proper name, a local hidden variable theory. Local, meaning nothing outruns light. Hidden, meaning the values are real but we cannot see them. Picture a notebook each particle carries. For every direction you might point a detector, there is already an answer written on the page. This was not a fringe position. Einstein held it. And for decades it looked untestable, because by construction you can never read the notebook. In 1964, John Bell found the crack, and the crack is this. Stop pointing both detectors the same way. If you always align them, a notebook explains the results effortlessly. So do not align them. Turn them to different angles, chosen independently at each end. Now the argument itself. I want to do this properly, because it is genuinely simple and almost nobody shows it. Pick 3 directions. 0 degrees, 30 degrees, 60 degrees. If the notebook theory is right, each particle carries an answer for all 3. Up, up, down, or down, up, up. 8 possible pages, and every pair gets issued one of them. And the partner carries the exact opposite page, because whenever you do align the detectors, you always get opposite results. So measure one particle at one angle and its partner at another. The two of you agree whenever those two entries on the page are different. Here is the whole thing. Look at the entry for 0 and the entry for 60. Suppose they differ. Now think about 30 sitting in between. It is either up or down. It has to be one of them. And whichever it is, it differs from at least one of the other two. It cannot dodge both. That is the proof. If 0 and 60 differ, then 30 differs from 0, or 30 differs from 60, or both. So across many runs, how often you agree at 60 degrees can never be more than how often you agree at the first 30, plus how often you agree at the second 30. Every notebook obeys that. All 8 pages, any mixture of them. There is no clever assignment that escapes, because this is not an argument about physics. It is counting. So put numbers on it. Quantum mechanics says 2 detectors 30 degrees apart give the same answer 6.7% of the time. Double the angle to 60, and the counting bound says you cannot exceed 13.4%. Twice the small number. That is the ceiling, and nothing carrying pre-written answers can cross it. Quantum mechanics predicts 25%, not slightly over, nearly double the ceiling. 2 theories, 1 experiment, completely different answers. Bell turned a philosophical argument into a measurement. It took time to actually run. John Clauser did it first, in the early 70s, and quantum mechanics won. Elaine Aspect sharpened it, switching the detector settings while the particles were already in flight, so that no signal leaving one detector could reach the other in time to matter. But experiments like these have loopholes, and they are worth naming, because closing them is most of the story. The detection loophole. Real detectors miss particles. If yours is even slightly better at catching the runs that agree with quantum mechanics, your sample is biased and the violation could be an artifact. The locality loophole. If the two sides sit close together, or the settings are chosen too early, then in principle a signal traveling under the speed of light could sneak across and coordinate the answers. In 2015, 3 groups closed both at once. Henson and colleagues in Delft used electron spins in diamond, more than a kilometer apart, with settings chosen far too late for any light speed signal to help. Giustina and Schaum led 2 photon experiments the same year, with detectors efficient enough to close the detection loophole. All 3 found the same thing: the bound is broken, reality is not carrying a notebook. Closser, Aspect, and Zeilinger shared the Nobel Prize in Physics in 2022 for this work. Now one honest caveat, because you will see this claim overstated almost everywhere. Bell did not rule out hidden variables. He ruled out local ones. There is a surviving theory, Bohmian mechanics, in which particles do have definite positions the whole time. It pays for that with explicit non-locality. In that picture, something really does reach across instantly. You can keep the notebook, but only if you let it be updated faster than light. So the real conclusion is a fork. Either the values are not there before you look, or the world is not local. You have to give up one of them. Most physicists give up the notebook. Which brings up the thing everybody wants to be true. Can you send a message with this? No, and the reason is worth understanding. Look at your own results without your partner's. Pure noise, 50-50 forever. There is nothing they can do at their end that changes the statistics at yours. Not the angle they pick, not when they measure, not whether they measure at all. The correlation is real, but it only exists in the comparison. And to compare, somebody has to carry the other list to you: a phone call, an email, something completely ordinary, crawling along at the speed of light. So entanglement gives you correlation without communication. Relativity survives, intact. One more question worth answering. If this is really how the world works, why does nothing around you behave like this? Because entanglement is fragile and it spreads. The moment a particle touches anything else, an air molecule, a stray photon, the wall of the apparatus, it becomes entangled with that too. The delicate 2-particle correlation gets diluted across billions of particles and stops being measurable in practice. That is decoherence. It is not that large objects are exempt from quantum mechanics. It is that large objects are impossible to isolate. And once you stop asking entanglement to send messages, it turns out to be extremely useful. 2 people sharing entangled pairs end up sharing identical random numbers that existed nowhere beforehand. Anyone who intercepts disturbs the state and shows up in the error rate. That is quantum key distribution. And in a quantum computer, entanglement is the resource itself. The bits in a classical machine are independent of each other. Entangled qubits are not, and that correlation is where the advantage lives. So, not 2 gloves in 2 boxes, a pair with a decided total and undecided halves. A correlation that no set of pre-written answers can reproduce, tested to exhaustion and confirmed every time. And a universe that keeps both sides consistent without ever sending anything between them. That last part is still, genuinely, not fully understood, which is the best possible place to leave it.